Stay safe, happy learning. Say no to theft of electricity for the first time every time. In this video, we will discuss tropical thunderstorm effect and its protection. Let us first find what damages can thunderstorm can impart to us. This is a control panel, damage due to lightning. This is an overhead line steel structure shattered due to thunderstorm. This is a tree bifurcated from its stem due to lightning. Welcome, I am Amarnath Misra, retired Chief Engineer from Jharkhand State Electricity Board. I am also a certified energy auditor. With the increase of high voltage overhead lines, the problem of lightning is assuming greater importance and much damage is done yearly by lightning. As reported in the state of Jharkhand itself, during the month of August 2024, more than 500 distribution transformers burned, more than 30 persons and 50 animals lost their lives and hundreds injured due to lightning. There are two main ways in which lightning affects a line: by a direct stroke and by electrostatic induction. The way in which thunderclouds get charged up to very high potential is a bit complicated and yet to be explained precisely by the scientist. A direct stroke can take place in several ways. In one way, the charged cloud induces a charge of opposite sign on tall objects such as tall masts, church spires, etc. The electric stress at the top points of these objects causes ionization of the air, and eventually a direct stroke takes place between the cloud and object. Such a stroke is known as the stroke A and is characterized by the comparatively long time taken to produce it and the fact that it strikes the highest point, usually a lightning conductor. Another way results in a much more sudden stroke, which is produced in the manner as shown in this figure. See, here there are three clouds and all three are involved here. And the potential of cloud 3 is decreased by presence of charged cloud 2. The potential of this cloud is decreased by this charged cloud 2. When cloud 1 flashes over to cloud 2, both these clouds are discharged rapidly. Then cloud 3 assumes a much higher potential and flashes to earth very rapidly. I repeat, there are three clouds involved in this B stroke. 1, 2, 3. Okay. When the potential of cloud 3 is decreased by presence of charged cloud 2. Due to attraction or repulsion, the potential of cloud 3 decreases due to presence of this cloud 2. When cloud 1 flashes over to cloud 2, when this cloud 1 flashes over to cloud 2, what happens? Both these clouds are discharged rapidly. Then cloud 3 assumes a much higher potential and then flashes to Earth very rapidly. This is the B stroke. This is a B stroke and is characterized by its rapidity and the fact that it ignores tall structure and reaches Earth in random manner. That is why at many places we find that the cattle at the field grazing fall victim to the lightning strokes. A direct stroke may cause a potential of more than 1 crore volt or 10 million volts and shatter insulators into pieces, as well as the trees and towers in its vicinity. The most that can be hoped from protective devices is that they can limit the damage and prevent the lightning strokes to a certain limit. But from direct strokes, there is not very much direct protection. These are lightning arrestors. Which is used for protection from lightning strokes. The majority of surges in transmission systems are due to lightning and are caused by electrostatic induction. One thing I forgot to tell you that fortunately direct strokes are very rare. Now, the majority of surges in transmission systems are due to lightning and are caused by electrostatic induction in the manner described in this figure. A positively charged cloud is above the line. This is a line. And a positively charged cloud is there above the line and induces negative charge on the line by electrostatic induction. The induced positive charge takes slowly to Earth via the insulators. When the cloud discharges to Earth or to another cloud, the negative charge on the line is isolated as it cannot flow quickly to Earth over the insulators. The line thus requires a high negative potential, which is a maximum at the place nearest the cloud and falls slowly to a small volume at a distance. The charge will flow from a higher to lower potential and the result is traveling wave in both directions. If voltage induced here is V, half V will be in this direction and half V will be in this direction. It will be in similar way as we switch on our system. The line thus acquires a high negative potential, which is a maximum at the place nearest the cloud and falls slowly to a small volume at a distance. The charge will flow from a higher to a lower potential and the result is a traveling waves in both directions. The two waves will be equal and thus each will have half the potential. The two waves will be equal and each wave have half the potential of the induced potential. The waves travels in exactly the same way as the waves due to switching, so that the current at any time of the line is the voltage divided by the surge impedance. In a line without resistance or leakages, the waves travel without change of shape, but effect of resistance and leakage is to attenuate the wave and to flatten the wave front. Now, as we discussed earlier, the protection against this lightning is the lightning arrestors. To some extent, these lightning arrestors definitely provide protection. So they have definite advantage, but they have some definite disadvantages too. They are that the high quality arrestors can be expensive to install. The cost of lightning arrestors varies exponentially from increasing voltage. I mean to say, if this is LT lightning arrestor, this is 11 kV lightning arrestor, this is 33 kV lightning arrestor, and this is 132 kV lightning arrestor, then its cost will increase exponentially with the increasing voltage. It requires regular maintenance to ensure optimum performance. All these will have to be cleared and cleaned every day and regularly so that optimal performance can be obtained. It may degrade over time and require replacement. That's all in this video. Thank you. Stay safe. Happy learning. Say no to theft of electricity. Please check your subscriptions so that you don't miss next video from this channel. Thank you very much.